Hello, this is Alexander. It's a pleasure to be here. Pleasure to be presenting to you guys on my project. In spite of these situations that we are currently living, I want to thank GS LSAMP and Dr. Geroge for this great opportunity in presenting my project. Today, I will talk to you guys and try to give you an idea behind my literature review, which is what I decided to focus on the past summer. I researched a lot of different areas of organic synthesis, but not quite enough to spark some interest until I came across the nature and chemistry of tryptamine and tryptophan, naturally occurring precursors. The halogenation and halogenative, specifically halogenative cyclization of these molecules basically provides an introduction into the understanding of natural products and their heterocyclic structure. This is in turn important because it enhances us a much more large knowledge behind what's the biological activity of these natural precursors. The idea behind the project that many research groups have been interested in is providing a more sustainable protocol than the traditional methods that involved the preparation of these compounds, including high temperatures, unstable solvents, and so on. We decided to analyze um, oxidative electrophilic along with phase transfer catalyst and some asymmetric approaches for this synthetic route. The materials are utilized for my project was ChemDraw. This software and program in particular helped me prepare and personalize my reaction schemes. I was able to play around with them, twist them in a way that is understandable for me, but is also understandable for the public. So it's a great source for this kind of work. Google Scholar was a reading platform that I used to obtain literature data. Not to mention the Journal of Organic Chemistry, the weekly video conferences I had with my mentor and peers to discuss my progress in the research. It was through these materials and methods that I was able to carry on with the project. The project started basically around May, um, and this month, first month consisted of learning how to analyze and read scientific articles, which before I had no knowledge of, and utilizing ChemDraw, how to annotate, how to read, how to extract information from articles. By the month of June, we developed into a more higher thinking, and then it involved more of a personalized idea behind what I wanted to do. So I began by literature searching and collecting articles on the hypothesis I kind of had in my mind and the topic I wanted to work on. By July, we already had pretty much everything collected and everything set up, everything was annotated in a concise way. This allowed us to start the process of drawing the schemes in such a personalized way, like I mentioned before. Um, by August, everything consisted of reading and preparing the schemes, making sure that they're communicating the necessary information, not leaving out any details. By start of the school year, September to October, the process of writing began. And as of now, that is where we are currently find ourselves in. So here are to our right, I prepared a general scheme just to give you sort of a visual present representation of what these different schemes are presenting. There are all basically following this particular pattern in the fusion of a five-member ring to our indole ring in our heterocyclic structure, along with the incorporation at this carbon position of the halogen atom, which in turn is what enhances those biological activities that will be of great interest, especially in the pharmaceuticals. Here to our left, this was a particular project that involved bromination and chlorination of tryptamine derivatives. To our further right, we have a halogenative route for the cyclization of tryptophan derivatives. The outline of the project will be based on pretty much available information, the most accurate and up to date data we were able to find, starting with fluorine, followed by chlorine and bromine. Um, and the results that we were able to find based on these um, findings and the research data we did, the annotations, extraction of information, and so on, is that even though this is particular small area of research that is currently being developed and it's outgrowing within the organic synthetic field, um, we can classify this protocol as sufficient enough to bring the results, the desired results, in a helpful and synthetic possible way. The most recent work indicates that introduction of these halogen atoms along with the ring fusion presents a really promising future, especially for understanding more of heterocyclic chemistry and the applications of synthesis of bioactive compounds. The idea is that we develop more efficiently these protocols. In conclusion, halogenative glycosation has honestly become a very fundamental transformation, and this is an observable feature I was able to find across all these different scientific data. And preparing this review prepared me and helped me understand more what is this chemistry behind heterocyclic structures that are naturally occurring in plants and animals, fungi. Um, Preparing this review, I think, will serve as a way to donate more literal information to the scientific community about what methods are more important and which ones are more efficient into the halogenated compounds as starting materials for possible protocols. We are currently working in the literature and the writing of the literature. So we are hopeful that and optimistic that we can possibly in the future present this review and its results for approval to a journal review. I would like to lastly thank Dr. George and Elsamb for the great opportunity they offered me with this project, for their stipend and for their help, for their resources provided. Not to mention the great help from Dr. Jing Thank you for your dedication and time and mentorship overall. Thank you all for listening.